Welcome to this video. We're going to learn about a concept called torque. And this relates to how hard it is to make something turn or rotate. So imagine you've got the following situation. There's a bolt that you're trying to loosen, so you put a wrench around, and then you grip the wrench here and you pull down with the force. If the bolt doesn't budge, what's the next thing you do? Well, you pull a little bit harder with a bigger force. Now, if that still doesn't work, what's your next resort? You'll probably slide your hand down toward the end and pull from there. And the reason is because anyone who's actually loosened a bolt knows that it's easy to turn from the edge than from the middle of the wrench. So why is that? Well, the position of your force is relevant. If you took your hand and you pushed directly on the pivot, then you're not going to do any turning whatsoever. So we've seen already that the ability to turn depends on two things. It depends on how hard you pull and also where you pull. This last one, the distance of the force from the pivot, describes are you pushing right on top of the pivot or did you move your hand really far from the pivot? But there's actually a third thing that also impacts how easy it is to turn. If you push the wrench in like this, then it doesn't matter that you're pushing really hard. It doesn't matter that you're all the way here away from the pivot. The fact that you're pushing at this angle means you're not going to do any turning. So the third factor is the angle or direction of your force. We summarize all of this with the following equation, and here it is at the very bottom. This is the Greek letter tau, and it represents the torque, which you can kind of think of as the ability to turn. F is the magnitude of the force, R is where you're pulling from, and theta is the angle of the force. Let's define these variables a little bit more clearly. Here's the wrench and you're trying to turn it, so you're pulling it at this angle. The equation for torque is at the top. Tau represents the torque on the object due to the force. F is the force on the object. So, where is force in this picture? Oh yeah, it's this red arrow. R is the position of the force, and we could think of that as the distance from the pivot. The pivot refers to where the object is turning. In this case, the object is turning around this point right here. That's the point that's stationary and doesn't move, so that is where we pivot. And everything else pivots around this stationary point. So okay, here's the pivot, here's where the force is applied, so what's R look like in our picture? It's the distance from the pivot to the force. Theta is defined in a very specific way. You might think theta is the angle from the x-axis or horizontal, or maybe you think that theta should always be measured from the y-axis, but instead we measure theta from R. It's the angle that the force makes with the R vector. So the angle between blue and red, that's this, shown in green. We know force is measured in newtons, R, the position or the distance, that's in meters, and theta will be in degrees. So what's the unit for torque? Well, the sign has no units because the degrees go away. R is meters times F newtons, so it's Newton meters. We're always going to plug in positive values for force. Even if the force is kind of down or looks maybe like it might be negative, we'll still put a positive value for the force. We're going to plug in a positive value for R as well, even if R points down or left, and theta will always be positive. So if all three of these are always positive, you might think torque can only be positive as well, but that's not the case. Torque can actually be positive or negative, and the reason comes down to this. Torque is a vector. The way to think about torque and its directions, positive versus negative direction, is by considering a clock. If you take your hand and you pull down, then here's the pivot, so everything is going to rotate around that pivot, or about the pivot, as we say. So the wrench goes down like that. You've just gone clockwise or counterclockwise? Well, you started up here and you went down clockwise. In torques, clockwise is negative. That's one of the two directions. The other possibility is that you take your wrench and you're going to turn it down, pull it down this way so that the wrench and everything turns like so. In this case, have you gone clockwise or counterclockwise? Well, you started at the top and moved down, and this is actually counterclockwise because the clock would turn around this way. So in torque language and torque world, counterclockwise is positive, or sometimes we call this anti-clockwise. That's the kind of the British term. Anti-clockwise, counterclockwise. There is no uncle clockwise, just anti. If you have two people pulling on the wrench, then what do we do now? Well, you can actually add the individual torques, T1, tau 1, and tau 2, from the two people, and get the net torque. You could plug in for each of these torques Fr sine theta. Let's consider the signs, because you have to make each torque positive or negative based upon if it's counterclockwise or clockwise. So, okay, where's the pivot? Oh yeah, the pivot's right here. So this is the point that doesn't move. Everything else moves around this point, either clockwise or it moves around counterclockwise. All right, so this first force here is going to pull the thing down like that. And is that clockwise or counterclockwise? Oh, that's clockwise, so negative. This second force, what about it? Does it make a positive or a negative torque? Well, it would try to pull the whole system like that, anti-clockwise. So anti-clockwise, that's positive. This would be a positive torque. Let's consider what the Fr theta look like for each of the forces. The F's are easy. Here they are, F1 and F2. The R's, remember, you measure R from the pivot to the force. So the pivot's right here. The force is applied here. This is R1. The second force is applied all the way over there. That's R2. And theta, what about that? Is it always measured from X or Y? No, the rule is theta is measured from R to F. So here's theta 1, the angle between the two arrows. Here's theta 2.